Hi there everyone. For this video I'm going to get into how to do the 80-20 rule within Excel. With that, for those of you who are not familiar with the 80-20 rule, it's fairly common within crime analysis. It's not garnered as much attention research-wise in recent years, and it really should, given what it allows us to do from a crime prevention standpoint, understanding where a crime occurs. So the 80-20 rule, depending on what field you're in, Pareto principle, Excel does it a Pareto chart, and that's what we're going to use. But what it refers to is identifying risky facilities. So if we're looking at bars, not all bars are truly risky for crime or calls for service. It's usually a subset of those. And typically it's 20% of the bars that account for 80% of the issues, calls for service, crime in general. Truly are risky facilities. And this obviously will shift some, and it's not carved in stone. It can shift and vary a bit based on the crime type you're looking at, the environment you're looking at as well. So it's just loose regulations when you think about it that way, or values, thresholds. But 80-20 is a principle to follow. So yes, it could be bars, it could be hotels, liquor stores, bus stops. Traditionally, 20% are risky for any type of outcome. With that, this made me think even more so in the past couple years since we did a paper looking at the 80-20 rule in Little Rock from a crime prevention or crime prediction standpoint with risk terrain modeling. So again, we're going to be using Little Rock data, looking at the 80-20 rule in relation to shoplifting and department stores in the city. I'll link to both of these. The risky business one here from the UARC people, and I'm one of them on it, might be behind a paywall, so shoot me an email if you'd like access to it. The EC one here I'd highly recommend. It gives you a great background and really an understanding of why risky facilities matter and what it means going forward, and why research should really take account for this when it comes to crime in place. So with that, the data set that I have in front of you is the same one that I used for the Google API geocoding aspect of it. I have the coordinates for both the department stores, and within the department stores, this came from the Treasury Department of Little Rock open data portal. I downloaded the business licenses, and then I filtered based on the classification to get major chain and discount variety stores. This is a subset of those. So we have 22 different ones. We have their address, the business name, and everything with that. And even from the Little Rock data portal, I also grabbed the shoplifting incidents for 2020, and it had the address and timestamp on it as well. Filter this, I used the Google API within Excel to get the coordinates, just so both data sets were in the same coordinate system or the same source using the Google API. Since the Treasury Department handles the business licenses and the crime data is coming from LRPD, they're using different sources to get their coordinates. You can even look here if you want to pause and compare. There are slight differences from the ones that LRPD grabs versus the ones I calculated through the Google API. That matters in the long run, and to reduce some headaches and lovely issues going forward, I went ahead and did this for us now. With that, we now have coordinates for each incident and also the department stores. So we want to aggregate and then merge based on that. So here, I'm just going to highlight the top row, Control Shift down arrow, gives me the table, and here I just want to insert a pivot table. It's going to open a new worksheet, and that's fine. And here I'm interested in the coordinates as my rows, each one's unique. And with that, I want to have the incident number be my count measure. So I'm going to move it over to value. And now I can see here, based on the unique set of coordinates, how many shoplifting incidents occurred at that specific coordinate set. So here, I'm just going to change this again to coordinates. The next one is count shoplifting 2020. Keep in mind, since this is a pivot table, it's pulling from our prior sheet. So I'm just going to rename this as pivot so we know what it is. But I'm going to copy and paste this into a new sheet so we can use it a bit more. So I'm going to copy, new sheet, paste it. You can see here, no longer is attached to the pivot table, separate, and I can use it a bit more. And this is important because now we have the sum per coordinate system, or coordinates itself, and I can link this to the department stores based on this unique ID set here with the latitude and longitude. So here, since I have the full address, I have the coordinates, now I want the count of shoplifting. So to do that, if you're familiar, and I have other videos on it, the VLOOKUP is going to take my coordinates here and then look at it compared to the other table array, and pull back the count that I need. So here, I'm going to start off with an error part to where if it doesn't have that coordinate, or if there's just no shoplifting incidents at that address, it's going to give me 0. So I'm going to do if error, and then first do the VLOOKUP, which is going to be the part where it looks up the table for us. I want to look up these values, but I want it to pull from the table array that we just copy and pasted here. And keep in mind, the count is in column 2, so here at the top when you see column index number, that's going to be the second column. And I want it to be false, so I want it to be an exact match. Then when I close that off, the VLOOKUP is done now, but remember I started off with the error part, so I'm going to do comma 0, so inputs is 0 if there's anything that does not have a value. To help out, I'm also going to lock the other ones by putting the dollar signs in, just so it gives it the full range of it. And hit enter, and you can see here the top one pulls back for Walmart 139 shoplifting incidents. I can go ahead and flash fill that downwards, and you can see here now we have our shoplifting list by store. Good start. Now let's get into making the table and understanding the Pareto principle, the 80-20 rule. So again, I'm just going to copy this. I'm going to take it into a new spreadsheet just so we can work from that and delete a few columns. New. And here I'm also going to paste values just so we keep the numbers here without losing anything. Since that was still based on the VLOOKUP, I'm going to move this to the end and just going to put the 80-20 down here so I know what we're doing. Since we have the address, I'm going to go ahead and get rid of some of the in-between parts just to clean it up. Before we do anything else, it's important to now sort our data. We want it from the largest number to the smallest. So I'm just going to highlight our data set here, go up to sort and filter, sort. It has header, so I already picked that. The count of shoplifting, change this to largest to smallest, and there we go. So now we have a good idea of what we're working with in terms of count per store. We want to get the sum of all of them so we know how many there are across these stores. Oops. Sum. I didn't put the parenthesis there. There we go. 463 across all of the stores. With that, we want to know the cumulative percentage that gets us to 100 of all of them in general. So here, cumulative, and this is where we're going to take the one prior and add it to the next one. So we have 139. For the second Walmart here, we're going to do the prior and then add our next one of 105 and so forth until we get to our 463, our last one here with the drug emporium. So with that, we now know a great part of the accumulation effect, but we want to change that to a percentage. So here, we're going to just change it to a percentage. And from here, we're just going to take our cumulative and divide it by the total. And we're going to flash fill that downwards as well. And as you can see, we need to make sure this is a percentage. But if you notice, what I did not do was lock in the D24 to make sure everyone after that is also pulling on that specific number. There we go. So it pulls it for us. Go up here and hit percentage, and we can see how it shifts over for us. And we can even see here in the first about 1, 2, 3, 4, we have about 80% of our total shoplifting across these department stores itself. So we're starting to see that. Because keep in mind, we only have 22 stores. So even if you want to do some quick calculator math, if we're looking 22 times 0.2, 4 to 5 stores is going to give us our 20%, which is good. We're in that range already without even looking at a chart. It's a good first sign. To make it more worthy to see and kind of visually see, we're going to highlight the main information and insert a chart. So here we're going to start with business name, and I also want the count of shoplifting and the cumulative percentage part to it. So I'm highlighting each one of these by holding down Control. Then I'm going to go to Insert. I'm going to click on recommended charts, and the first one it picks up is ideally the one we need. But also if you go down to histogram and then the second one here, the Pareto, you can see here it's going to be our 80-20-1. So I'm going to click OK, and it adds it in here for us. I'm just going to enlarge it some. I'm going to change it to where it's a bit darker so it's easier to see. But as you can see here, it has our count on the left side with our count of shoplifting incidents. And on the right side, you see the percentage of the stores itself. So you can see the Pareto principle, the 80-20 rule, very simply in Excel, straightforward. And you can change the display options with it. Excel gives you a lot of options to play around with, make it more visually appealing. And you have different layout options with it as well. This is just a quick one of how to analyze the 80-20 rule with one specific type of crime and a specific type of facility, this being department stores. Keep in mind that the classification was based on the Little Rock Treasury Department and how they classify those. You could pull out different ones, and I will in the future. This is just an easy way to pull the data that you have access to that's spatial in nature, aggregate it, and then look at how the 80-20 rule acts with real data in real time. If there's any questions, please reach out to me. Always happy to make another one with it. If not, enjoy. Also, for those who stuck around, quick afterthought, if you're interested in how this looks spatially as well, since we have the information in front of us, we can also just insert a 3D map. So I'm going to highlight this data set here with just the count. I'm going to go into insert, and we have a 3D map, open 3D maps, and it's going to pull this data in for us, and it's going to generate. We have a couple different address fields, so we have the full address, we have the coordinates, and we also have the count that we want to display, but these will visually represent the data for us using Microsoft Bing. It's a nice addition to it. Give it a bit of time. It takes a second to open up the map in the first place. After that, it's fairly easy to use, and you can export out of it JPEGs, PDFs, pictures out of this, which is pretty handy going forward. All right. So we have our data here, and it's asking for a location field. So we want to add a field, and we're going to go ahead and put in the coordinates. And it wants those separate, so I'm going to go ahead and add another field and do full address, and this one's going to be just full address. Click that. There we go. And we're going to zoom into Little Rock now. And now we can see where they're located within Little Rock itself. If you're not familiar with Little Rock, we can add some other options to it. Let's see here. Depending on your preference, you can also add different locations, map labels. But now we can zoom in a bit. If we want to add height, we can do the height based on how many incidents there were. So here we could do the count of shoplifting. And you can start to see, and you can tilt it where they're located within the city itself. You can see pretty close access to the interstate here and here. Keep in mind this is shoplifting only, so it's the sum of. That gives you a good working idea of where those stores are located across Little Rock itself. This one's not meant to be a heavy mapping one, it's just a way to display the 80-20 rule itself. You could even mark the 4 to 5 that are problematic. Obviously we can see here that these 3 to 4 are going to be our heavy hitters, just given how many and how high that bar is itself. It gives us another talking point when we're talking about crime prevention and preventative efforts, even outside of policing. So if there's any questions, please reach out. If not, enjoy.